I'm diving into the exciting world of Sklearn, specifically focusing on two crucial cross-validation techniques, K-fold and stratified K-fold. We'll unpack what makes them unique and when you'd choose one over the other. It's all about how we split our data to fairly evaluate our machine learning model's performance. Get ready to learn. I've got a dataset with 100 samples, and I want to use cross-validation to rigorously test my machine learning model. I'm aiming for 5-fold cross-validation. This involves splitting my data into 5 parts, training on 4, testing on 1, and repeating this process until every part has served as the test set. But how I split those 5 folds is critical. That's where K-fold and stratified K-fold come in. Let's analyze the options. Let's say your data is ordered in some way that could skew results. Maybe the first 20 samples represent one distinct characteristic, and the next 20 another. Without shuffling, K-fold might consistently place those similar samples in the same fold, introducing a bias. By using shuffle equals true, we randomize the data before splitting, reducing this risk and ensuring fairer folds. Shuffle is a game changer for unbiased results. Stratified K-fold takes a bit longer to process. That's because it doesn't just split the data, it does so while ensuring each fold reflects the overall class distribution in the data. It's like arranging a perfectly balanced team. More work, but a much fairer and accurate assessment. K-fold is straightforward. It divides the data into consecutive chunks. No fancy adjustments for class balance. Hence, it does not guarantee that every fold will have the same proportion of each class as the whole dataset. Stratified K-fold is designed to maintain the class distribution across folds. If my dataset has an uneven split of classes, stratified K-fold makes sure that each fold mirrors that proportion. This prevents bias in results and is super important for imbalanced datasets. Fairness is key for accurate model evaluation. This simply tells us the size of the data we're working with 100 samples. This informs the cross-validation process by determining how many samples are in each fold. This is the name of a function in Sklearn. It's a basic way to perform K-fold cross-validation. It splits your data into K consecutive folds without worrying about class proportions. This is another Sklearn function, much like K-fold but smarter. It splits the data into folds, but it makes sure that the proportion of each class is roughly the same in each fold. This is essential when dealing with datasets where classes are not equally represented. I'm focusing on the core difference between KFOLD and stratified in Sklearn, which are both used for cross-validation. They are both ways to split data into folds for model evaluation, but they differ in how they handle class distribution. I'll explain how both approaches work. I'm using 5-fold cross-validation, meaning I'm splitting the data into 5 separate folds. Each fold will be used once as a test set, while the other 4 folds are used as the training set. This helps to get a more robust measure of how well my model generalizes. This process is repeated 5 times to train and test a model 5 times. I have a dataset with 100 samples. This is a relatively small dataset, so it's even more important to use a technique such as cross-validation to make sure the model does not overfit. I'm investigating 4 statements to determine whether they are correct or not based on the data and my understanding of KFOLD and stratified. I will focus on their properties and how they perform the fold splits. This statement is false. KFOLD does a simple split without considering class balance. It might end up with uneven class representation in the folds. This statement is true. Stratified ensures that each fold has roughly the same proportions of each class. That's important for datasets with imbalanced classes. This statement is true. Setting shuffle equals true in KFOLD randomizes the data before splitting into folds. This helps to prevent bias from any inherent order in my data. This statement is true. Because stratified needs to consider class distribution, it's a bit more computationally expensive than KFOLD. I'm discussing the differences between two crucial cross-validation techniques in Sklearn, K-fold and stratified K-fold. We'll explore how they work and when you'd want to use one over the other. I'll be working with a dataset containing 100 data points. This dataset size will be used for the cross-validation examples. I plan to split the data into 5 groups, folds, for cross-validation. This means I'll train my model on 4 folds and test on 1. Repeating this 5 times, each time with a different fold as the test set. I'll evaluate 4 statements related to how K-fold and stratified K-fold handle data splitting in cross-validation. I'll use my understanding of these techniques to determine which statements are correct. This statement focuses on stratified default's core feature, maintaining the same proportion of each class, like positive or negative examples, across all the folds. This is super important when dealing with imbalanced datasets, where one class has far fewer examples than others. Here, I'm looking at whether randomly shuffling the data before applying K-fold helps reduce bias. Yes, shuffling is a key way to avoid bias caused by any inherent order in the dataset. I'm considering the computational cost. Because stratified K-fold needs to ensure proportional class representation, it involves more steps than a simple K-fold split, making it slightly more computationally intensive. This statement is false. K-fold simply divides the data into consecutive chunks. It doesn't consider class proportions at all. I'm comparing 2 ways to split data in Scikit-learn for cross-validation: K-fold and stratified K-fold. They both divide data into groups for training and testing models, but they do it differently. Think of it like dividing a class into groups for a project. K-fold just divides them sequentially, while stratified K-fold makes sure each group has a similar mix of students with different skills. No, K-fold doesn't promise to maintain the proportion of different classes within each fold. Imagine you are dividing students into groups based on their skill level: beginner, intermediate, advanced. K-fold might create groups with uneven numbers of beginners, intermediates, and advanced students in each group. Yes, stratified K-fold makes sure that each fold maintains the proportions of different classes. Using the same student example, this approach guarantees each group has a similar representation of skill levels: beginners, intermediates, and advanced. This is especially helpful when some skills are rare, preventing bias in model evaluation. Yes, by adding shuffle equals true you are randomly rearranging your data before splitting it. This avoids potential bias from the original data order. For example, if your data is ordered by some characteristic that correlates with your outcome, then not shuffling would lead to a skewed evaluation of your model. Yes, stratified K-fold takes a bit longer to run because it needs to figure out how to keep the class proportions balanced in each fold. An extra step K-fold doesn't need. It's like comparing sorting a deck of cards versus sorting it and then organizing it into suits. I'm doing 5-fold cross-validation using the K-fold method. This means I will split my data into 5 groups and will train on 4 groups and test on the remaining group, and repeat that 5 times with a different test group each time. It's a simple, efficient approach, but it doesn't guarantee balanced class representation. I'm also doing 5-fold cross-validation using stratified K-fold. This will ensure that each of my 5 folds contains similar class distributions as the overall dataset, which is particularly important when dealing with imbalanced datasets. It's more computationally expensive but more robust in class imbalanced scenarios. This question tests your understanding of how KFOLD and STRATIFIED KFOLD work in Scikit-learn for splitting data in cross-validation. I'm asking you to identify which statements correctly describe their behavior and differences. This statement is false. K-fold simply divides the data into consecutive chunks. It doesn't ensure that each chunk has a representative sample of each class. This is true. Stratified K-fold actively works to make sure each fold contains roughly the same percentage of samples from each class as the entire dataset. This is really important for imbalanced datasets to avoid bias. Absolutely correct. By using, I randomize the data before splitting it into folds. This helps reduce bias that might result from a specific ordering in the original dataset. True. Because STRATIFIED needs to consider class proportions while splitting, it takes slightly longer to compute compared to KFOLD. We have 100 data points to work with in this cross-validation exercise. I'll be splitting the dataset into 5 folds for cross-validation. This is a common technique for evaluating model performance. A simple method for k-fold cross-validation that divides data into consecutive folds without considering class distribution. A variation of k-fold cross-validation that ensures each fold maintains the class proportions of the original dataset. Using the argument with kfold randomizes the data before splitting to reduce bias caused by potential order in the original data. This is a more sophisticated version of k-fold cross-validation. It's designed to handle imbalanced datasets. It maintains class proportions in each fold, resulting in a more reliable evaluation of the model's performance. I see k-fold as a simple method. It divides your data into groups, folds, sequentially. Think of it like slicing a cake. You get even slices, but you don't care about the different ingredients, classes, in each slice. Nope. K-fold doesn't ensure each fold has a similar mix of your different data types, classes. No, k-fold does not actively maintain the proportions of different classes across the folds. It just divides the data consecutively. Yes, by shuffling the data first, you avoid any biases from the order your data originally had. It's like shuffling a deck of cards before dealing. You get a fairer hand. No, k-fold is computationally cheaper because it's a simple data split. Stratified k-fold is like a smarter sibling. It's similar to k-fold in dividing the data, but it also makes sure each fold has a similar representation of your different classes. Like making sure each slice of cake has similar amounts of each ingredient. This is great for imbalanced datasets, where you don't have the same number of samples from each class. Yes, that's its main job. It ensures that the proportion of classes in each fold mirrors the proportion in the overall dataset. Yes, absolutely. Stratified k-fold works hard to maintain class proportions. Yes, just like with k-fold, shuffling first makes the results fairer. Yes, because it does that extra work to balance classes, it takes a bit longer than simple k-fold. I'm focusing on two important functions in Sklearn, a popular Python library for machine learning. ~k-fold and stratified k-fold . Both are used for cross-validation, a technique to assess how well a machine learning model generalizes to unseen data. They both divide your data into subsets, folds, train your model on some subsets, and test it on the remaining subset. The key difference lies in how they perform this division. We have 100 data points, which will be split across the folds of our cross-validation process. This total number of data points will be divided into folds. This is the core question. I need to understand how ~k-fold and stratified k-fold work to determine which statements are true. K-fold is a basic way to split data into folds for cross-validation. It simply divides the data sequentially. Think of cutting a pie into slices. The slices aren't necessarily the same size or contain the same type of filling. It doesn't consider the class distribution of your data. Unlike k-fold, stratified k-fold makes sure that each fold contains roughly the same proportion of each class or category in your dataset as the whole dataset. Imagine cutting a pie with different fillings. Each slice contains a similar proportion of each type of filling as the entire pie. This is especially important if your data has an imbalanced distribution of classes. This is an optional parameter that will randomly shuffle the dataset before splitting into folds. This prevents bias if data is inherently sorted in a way that affects cross-validation performance. By shuffling your data first, you ensure a more random split, preventing potential bias due to the order in which the data points appeared in the dataset. This produces a fairer representation of cross-validation results.